Next. Yeah. Yeah, he's the
Hello, Professor.
Okay. Can you say something so that we check that one can hear you?
Yeah, I can hear you.
Okay, very good. Hello, Lola. Hello, Lina.
Hello.
Hello, Boston. So, who is that here? Sarah. Okay. Well, it's not okay, but we should keep going. We will do today stuff that was not done last time. Bottom, nurse. PMD is most spectacular and important, and I want to count that you have installed it. And for me, it is on the laptop that I have forgotten charger, so I will try to minimize time with VMD, although it is most prudent. So first do things that we can do without it, and then I will start showing what to do from this software. And we agreed that the homework that was due today, there was a request to work on it a little longer, right? Which is on this. Hello, Sarah. Nice seeing you connected. But I'm bargaining. If we extend the homework, then there will be one more point in it to do towards next Wednesday, and it will be based on the things that we are going to do right now. So the thing that we are. Yeah, that's good. That's good. Okay. So we're going to shift molecular dynamics, and they can be done either on Odin or on NERSC, but on NERSC it is like 100 times quicker. So it's a little less comfortable to do on NERSC, but it is much quicker. So it's either here or there. And then we will actually do visualize from heating to molecular dynamics, and then molecular dynamics either from NERSC or from Odin are visualized with VMD. I will show, and since it is the only task today, I'm quite confident we will go until we will cover this material, and all remaining things towards presentations will be covered next time. It will be a little larger number of things that they will be quicker to compute and simpler to understand. And this one will be the key skill for the project, and then it takes a larger amount of computational resources. Yeah, this is a really great product. Oh, okay, you want to attend twice. So let me quickly cover what is molecular dynamics, although you all, and I believe especially Sarah, are quite confident and can instruct us about it instead. I apologize. I want to tell it myself, although maybe it would be more interesting to ask you to share. So the standard task that any computational chemist and material scientist is doing is optimization of geometry. We kind of skipped it because it relates. I have a very clear mind, but scrambled speaking. So some of you were expressing concerns and complaining that like two attendees of this year class are sitting shoulder to shoulder, doing the same homework for the same model and getting completely opposite results. Right? So there is a reason, because I didn't emphasize the importance of geometry optimization. So if one performs geometry optimization in the right way, then the results will be the same. And in some sense, geometry optimization is more art than science. So one needs to look on the intermediate geometries and correct some parameters. So it would slightly delay our overall progress, but it is more or less standard thing. That you have the template of the in-car that you're using to generate wave current. There is a parameter NSW. If you increase it to like 100 or 1,000, it will bring system to optimal geometry with some hidden tricks, but basically it's nothing to instruct. It's more like practice. So geometry optimization means positions of ions can change iteratively at each step, and they ideally move towards mean, right? If this is some hyperatomic distance, it comes to equilibrium distance for each of the degrees of freedom. The molecular dynamics is, and at each iteration, the velocity or momentum of this particle, of this ion is zero. Right? So what if we start at the initial geometry away from equilibrium, and then we assign a momentum? What would happen? Yes, so if the potential is quadratic, it will oscillate, and basically it will move along this line with constant energy. And at each step of the trajectory, there will be partition of the energy between kinetic and potential. As I was drawing, it should be a little so that initial time have zero kinetic and potential. Right. So their relative partition may change, but overall energy is constant. Now, oh, Steven, happy to see you. What if we start? Suppose we have a code that does molecular dynamics that allows to see how the position of the ion depends over time. And if you started away from equilibrium, it's naturally will go. If you like expand the rubber, you contract. Right? What if we start from equilibrated germ? What if you start literally above the minimum and do not assign initial momentum? Will the particle move? If we start here, no kinetic energy, only potential. Yes, yes, it will stay the same, right? But if my goal is to describe motion, and if I assume as a person who attempts to be a scientist that I want to model a material on a thermostat, that there is a heat bath, there is a like stove that communicates some kinetic energy to each ion. We need to model this process. And if we are staying in the equilibrium, we need to tick the model and assign it some kinetic energy, or at the same time, it's assign some zero momentum. And then it will start to move. But what if it moves a little bit here, and at this point, the kinetic energy will be smaller than right? This blue stuff will decrease over time. We can try to keep it once again, and maybe with motion in the opposite side. Then it will start moving. Here it can be a little bigger. If we can keep it once again to have a kinetic energy smaller. And then we can follow this trajectory and keep it by rescaling, resetting the momentum to the needed value again and again, so that in average, after several kicks, it will equilibrate at the value of kinetic energy that will be proportional to the temperature, right? And if one wants some equations, it should be something like 3 parts or 1 kT per degree of freedom. And if we have 10 ions and each of them has 3 degrees of freedom, then kinetic energy should be this much. And momentum that we assign here should be, if this is equal mass momentum. Oh, then we take 2 mass times number of ions times 3 times. We take square root and it will be initial momentum that we want to assign each time, right? So, in order to model thermal equilibrium, one release from equilibrium or one kick is not sufficient. And right now, you could be under stress and you may haven't yet expressed you may haven't found the words to argue with the instructor, but you'll be not surprised if inside your hearts and brains you want to develop an argument against stuff that I told. And this argument would be based on what is shown. So how can one speak about average kinetic energy or temperature if you have 1 degree? At each time it will be very certain value. And if you scale, it will be either too much or either too few calories per this degree of freedom. So the answer is if you have sufficiently large number of degrees of freedom, then energy in each of them, energy will be bigger or smaller than the value corresponding to thermal equilibrium. But in average, if we distribute energy over, and big is maybe 30, 10 atoms, 3 degrees of freedom for each, it will be quite good near the equilibrated value. But in order to achieve this equilibrium, one needs to make several kicks, or good word for canoe is velocity restraint. Velocity restraint. So what I tried to deliver here was the heating procedure. As soon as we arrived to initial moment, initial positions, we can just start solving Newton equation of motion, or to solve for position as function of time. And this force will depend on not only on positions of time, but also on the electronic density at each point of speed. So when research group of Professor Shah, which is attended by Kia and Sarah, are doing molecular dynamics, this force, the forces are predetermined for each interatomic distance, which is good for small atoms like carbons, oxygens. But as soon as we go to heavy elements like uranium, there is a lack of high quality force because interatomic force also depends on angles, and it may depend on electronic state if something is excited. So the reason to use DFT instead of force field is that forces between atoms depend on electronic structure. So we are going to run 2 jobs on each platform, 2 on photon, 2 on poly, and then we will run about 6 jobs as an additional part of the homework for models that we were characterizing before. You will run this heat and molecular dynamics. So why we need 2 jobs? And I apologize for not setting it up as a discussion, which would be more constructive. I'm just trying to save time. Maybe when after the break, after the presentations, we'll return back to discussion stuff. So the connection between heating and molecular dynamics is thermal equilibrium. If you start at ground, at equilibrated geometry, molecular dynamics will not go for it. If you start just after 1 kick, it will be quite far from equilibrium in several degrees. So the heating or modeling of the thermostat is needed as a preliminary step towards molecular dynamics in order to set initial conditions. And this little arrow that connects heating and molecular dynamics, this little arrow will be symbolized by one specific command, which is quite easy to memorize, and I think you will not argue about it. So after heating is done, so this arrow, copy CP space point pi space into force pi. So it means the geometry that was generated at the end of heating stage, final geometry at the heating stage, will serve as the initial geometry for the molecular dynamics stage. So, and the file on car will contain both positions of ions, just a second, and momentum of each ion. Yes? Yeah. Okay. I was trying to be ready to answer any question. So I was not counting sentences, so I'll repeat the last page. So there are two jobs: heating and molecular dynamics. Our goal is to run molecular dynamics because we want to see response of materials to heat. But molecular dynamics, which is our goal, cannot be done without heat. Before we run the so-called empty job, and each job in Flask corresponds to like running Flask command with specific income. And there are specific incars for heating and for molecular dynamics. But in addition, there should be connection. Last geometry of the heating stage, which is stored in the file postcard, needs to be cut into the file postcard, which will be initial geometry for molecular dynamics. I remember from previous years complaints to me from those who were doing homework based on this skill, telling like, I am running molecular dynamics and my atoms are not moving. What is wrong? And this is if this step is skipped, nothing will move. Because we typically start from a liquid gel. So it is very simple but critical. So I will quickly show how to run both steps on photon, and I will set number of ionic steps quite small so that it can be completed in a reasonable time. And probably right away I will move and run same type of jobs of those. And after this demonstration, just to save time, let's prefer to have a little longer demonstration. I will make a tour and talk to everyone to see how you are doing it, help as much as I can. And it should take about an hour demonstration and checking. And then the last half an hour, when results of the molecular dynamics will be ready, I will do demonstration how to visualize it with BMT. And last two letters stand for molecular dynamics. What I will not show, but I hope that the great person who will present the subject presentation is how to install additional unit, additional that helps not only visualize molecular dynamics, but also save it in form of a movie that one can upload to YouTube.
Professor, that one is the another software video.
Yes, it's quite simple. You just look online, download, and install. But if I start instructing on this, it will eat about half an hour of our time. So let me leave it to the one who will volunteer to present molecular dynamics, and the person will deliver it for all of us.
Professor, is it possible?
Video Mac is on PC. On Apple Macintosh, things are a little bit different. Start, set. Oh, no. Last thing before we go to demonstration. So after molecular dynamics is done, we will open file out car by BMT. And just by opening out car that contains some motion of ions with BMT, one is able to see how atoms are moving. Whew. Okay, I'm starting to share the screen and making demonstrations. I see some questions in the chat. Equation part again. Let's maybe do through demonstration, and then after we are done, because time is limited, I'll go to explanations. So So suppose I do have healthy input files for VASP or one of the models from previous time, and I will be working with titanium dioxide nanowire. Points, and that's it. I do not need it. I copy, and now I am on the photo. I just started with LAB10, and to have a clean experiment, I starting over. So I do have healthy input files, and just in case I just was looking through your homeworks, and I'll repeat some basic things. So the Oscar. So I see that there are first element is oxygen, second element is titanium. Then I do rep PPE or Oscar. So there should be list. First element in this list should be the same as the first element in the postcard. Second element in this list should be the same element as in the postcard. If you see mismatch between files postcard and podcast, it's not good. It means your calculations will generate something crazy or maybe interesting but not applicable to real world. Now I need to copy the template. Copy. Okay, you want to try it the third time. So I in car dash hit. I copy to this directory and I rename it into the standardized name in car. Now I do have 4 input files, and I'm opening the file in car. And check what I can do there. So I have forgotten to share to all of you the link to VASP manual on the developer website. And please remind me to do it, or just find it yourself. If you just type in Google VASP manual, it will pop up. And you can succeed in the course without reading it, but if you have curiosity and lots of time and energy, probably they explain things better than I do. So here is the template of the IMCAR for ramping, for heating. And most important keywords are here. Ibrion 0, and the N block corresponds to kicks. So it means how often I kick, and I allow system to interface thermostat. So it gets rescaling of velocity and then keeps going. Beginning and end temperature. If I want to in Kelvin, so if I want to model room temperature, I put this one. If I want to be crazy or just have some fun, I can put like 3000, where most of molecules will decompose. It will be just more vivid and interesting. Or I can be in the intermediate regime, like 1000 Kelvin. Maybe it will not break the molecule, but at least it will be something visible. Beginning and end. If any of you are synthesizing thin films for and semiconductors and insulators like solid materials, there is a programmed ovens. When one carefully ramps temperature, not instantaneously, to avoid cracks. Right? So one can select one beginning temperature and different end temperature. So it will slowly ramp up temperature and avoid instantaneous jumps. And I'm not doing a gentle experiment. I just want to have vivid things. And another parameter to modify is MSW. So if this is how many ionic steps I want. 300 is a good number, but it is not practical for photon. So 30 will be the quality will be low. You will be not at the equilibrium, but it will be done in like maybe half an hour or 15 minutes. Okay, and after I do this modifications, I can escape colon WQ, and after this I will start the beam wasp.
So Professor, from we need to copy those files from our previous lab?
Yes, yes.
Okay.
So I did started this job, but if you let me know if I need to show previous commands. Yeah. Okay. So that it will continue running, I can note and put 1%. Hopefully it will not garbage the screen. Okay, and now I can scroll to the here. What? Oh, yeah, it was not much. So I did copy postcard, podcar K points from the previous one. What else? Then I did double check that the postcard and K points coincide to each other, that they agree, both for in this specific run is for titanium dioxide, for oxygen and titanium, and then I just copied the template of the INCAR, and then
copy that command, that cp incur.
Yeah. Okay. Yes. Copy. Paste. Okay. So, oh, I did copy it only to K. Let me do it for everyone. Good. Now, oh, I do PW and learn where I am at the photon. Copy this. And in the other window, I want to log into Corey. Let me just quickly, maybe it was not original plan, but I better make a circle and make sure that you all have submitted jobs. Otherwise, I will be mumbling for myself without knowing if it was helpful. So. Let me just check. Okay, foods for Thursdays. Oh, 1,300. It's just more interesting. If you put room temperature, it will be very lazy and not be required temperature. Right now, we just need for demonstration the weighted one. For example, if you want to model chemical weight, which is not happening, so 0, you have to activate all kind of okay. everyone a co-host. Yes. 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 But in fact, we need only Sarah and Kay to share screen. Sarah, would you like to share screen?
Yes, sure. So I created the LAB10 directory and heat directory and copied the key point, postcar, and podcar files from previous lab session. And I also execute this command for the in-car to, and then I use VI to edit the in-car and put 1000 for the temperature beginning and the end, and NSW for 30.
Okay.
Everything is okay now?
Yes, yes. Can you please launch WASP job here? Just typing tilde/bin/WASP button.
Tilde/bin/
WASP-button. Enter. Okay. And then we just need to practice patience for 30 ionic steps. So right now, this 1, 2, 3, those are electronic steps, and after about 20 steps, it will go to next ionic. So it will be approximately a minute, maybe a little shorter per ionic step here.
Yes. And Professor, could you please let me know how to check the two files that you said they should they should have the same order? You said that titanium, if titanium is first and oxygen the second.
Yes. Let's do it when we visit next time in about 20 minutes. So I do not want to stop your job. So let it finish.
Okay.
So yeah, it looks like everything goes well, and I'll visit once again with everyone after the job is finished. So please stop sharing, and Kia start sharing.
Also, I need to change here.
You need to change most important, yeah, down. If you want, you can change this number, but most important, keep going down to the ionic relaxation NSW equals 300.
This one.
So make it, do it 10, so it will be 30. Otherwise, it will be like 10 hours on a footing. Now escape colon WQ just to end and save. And
copy those files.
Launch WASP tilde/bin/wasp-button.
Tilde. Tilde bin. No, tilde bin. Yes. Tilde bin. BAP.
Dash minus photon.
Minus
Not underscore, but
minus
yeah, this one. Enter. And now you need to wait about 20 minutes until it is done. So you can stop sharing. Okay. I will show how to do the same operation on the NERSC. you can either follow me in the second window or postpone viewing it to the time if you watch recordings. But I want to show it because for the projects, use of photon will be not practical. So I want to make sure that you can access. And in fact, I already done it here, but I want to show it like for the clean experiment to. So I'm exit from NERSC, go into the coordinate directory, and here is the command how I connect there. Copy, go into chat, paste. Also, please remind me, I would like to make an activity to that each of you is getting personal account on this NERSC supercomputer facility. It's just it is for your benefit, not for my benefit. Therefore, I'm forgetting about it, but I will happily arrange it.
What, Professor?
Huh?
What you forgot?
I haven't forgotten, but I will forget. Please remind me so that I help each of you to get a personal account on this national supercomputer so that you use your own account by logging into there.
Okay.
Okay. So log in there. And then the tree of subdirectories is quite complicated, so I cannot memorize it. So I wrote a little help to myself. So more where, D, global common file system, C directories, M1251. So let me copy paste this stuff here, because for me, the most complicated thing in this activity is to go to the correct directory. Maybe for brighter brains, it's not a challenge, but for me it is. So now I'm going to CD CHEM676 2021. And then I'm going to my directory, but you can go to yours.
Should we connect to the query, Professor?
Yeah. Yes. Look at me. There I did open two windows on MobaXterm. One solely for Photon, and another where I first log into Photon and then from Photon to query.
Yes.
So the command that I did show here, this one, will work only from Photon. If you type it directly from MobaXterm, it will not work. It refers to some hidden files on the Photon that I renew every day to allow this quick connection. Okay. This 10. So suppose I want to do a clean experiment. So I am creating a new directory, make directory heat 1. Go into this directory. And then I am going to copy. So here is the command, but please adjust it, and I'll explain it, probably build it from scratch. But I'll show what this command is and how I do it. So I'm going to the window where I'm operating Photon and copying the path to the directory where I was working with all input files. Then I am going to the window where I'm logged into NERSC, and there I type rsync, which is, I can type instead, I can type SSH, but rsync is a command to copy large amount of files, which will work. For example, if I want to copy movies or large orbitals where the transmission can be interrupted in the middle and then started from where we left off. So rsync -AV. Then I type use where I want to take files, sources, user, host name, and then here, don't forget the column. Here I paste. I paste the path to the directory on the Photon where I have already created input files. And I want to copy everything from there, space, period to here. I hit enter, type my password on the Photon. And if I didn't start running WASP on the Photon, it will copy on the input files. If I did start it, it will also copy the intermediate files, but they're not big, it's fine. So since I am on the NERSC, I can return back this number of the steps to 300. For NERSC, it is nothing. It will be done very quickly. Thank you. And I need to copy and then I copy templates of the job submission scripts into this directory. So this job submission scripts are important, and they interface myself as a human on the front end and the actual cluster. Later on, we may need to, for the project, we may need to modify this file. For example, use larger amount of time. Now it is only 30 minutes, larger amount of cores, larger amount of nodes, and a little bit slower queue. So this debug queue is the quickest. But for educational purposes, it's more than enough. If you will start doing real models, one should replace the word debug with regular. Now, after I have done this, I submit WASP job by the following command. Just a second, I will copy this one, this command, copy and into the chat line. Okay. Now to submit WASP job, I type yes, batch debug.sh. Also copy this one to everyone. So after I did submit this job, it gives the job number. And when you are running WASP-photon on the photon, it gives you output in the command line. And we are a little bit violating the good practice of use of the computer, because there will be several instances of WASP command running. But as we do little short jobs, I think Steven will forgive us. But if you start doing something big, with his power, he may just kill the job and stop it. For the big clusters, instead of submitting it in the command line, one sends the job into the queue. And after the so-called batch job, after this batch job has started, one can watch progress of this job by typing this SQS grep and then index of the job. I will copy this command, but with understanding that you should use your own job number, job ID that will be issued after you submit the job. And if you are watching it a couple of days ago, this unique job number will be not more active. The job will be done in like 5 minutes. Yes, it's like a CCAST. Yes, it's just a little bit more powerful than CCAST. Okay. And if yeah, thank you. And if I want to see the progress, like one way is to do arrow up and try it once again. But and then again. But as a lazy human, I may not like to type this arrow up, enter, arrow up, enter. There is a way to monitor it continuously. Watch apostrophe, the command that I want to repeat, apostrophe. And then it will update. So the job is still running. It has been running for 2 minutes and 49 seconds. And in this watch command, I can put, for example, ls-lt to see how the files are progressing. So you see that file out card becomes bigger and bigger. So it accumulates more data. And Control C to stop. And I can also add tail out OZCAR. So it shows how many steps are passed. So by now, in this 3 minutes, 95 steps are passed, and present value of temperature is like 900 Kelvin, 800 Kelvin. So it reports what is going on. So let me copy this command to everyone. Copy. Paste. And Please practice it on your own for the sake of the time that I fear to lose. I will immediately go back to Photon, and I expect that the job I have submitted there should be done. So I will go to the next stage to doing molecular dynamics on Photon. So CCAST is more preferred, but just if you do both with a visit, will be over time substantial. So on the Photon, I do tail out car. So it shows this. If it shows user time, system time, it's a signature that the job has been completed successfully. So the only thing I need, so now I'm going to do what I did announce. I will create new directory, one level up, 2 dots, divide, MD, and I can try to be organized and type like MD 1000 Kelvin, because later on for research I may try MD at different temperatures. So make directory, and now I will copy the files that were output of heat job as an input for MD job. And my primary thing that I want to copy is cont_car. Copy cont_car into there, and I want to call it pos_car in this new directory. And in addition, I want to copy there the key points and pod_car potential. Just for, so most important command is here. Okay. So just before I go forward, let me make a little illustration. So I do more cont_car. What is inside this file? So the beginning of the file looks very similar to the postcard. If we, so cell size is the same, and if you look for positions of individual atoms, they will be distorted, but not drastically if you are not modeling explosion. But after last Cartesian coordinate of the atom, there is another segment. See, and it is different to what we had before. So there are total 8 plus 4, 12 atoms. 1, 2, 3, 12 Cartesian coordinates of each atom, and then we have again series of 3 coordinates. What are they? Yes, exactly. Make sense? Velocities. So the first line here gives velocity of the first atom in the model. So velocity along x coordinate, along y coordinate, along z coordinate. And I think units are like angstrom per femtosecond. So they're quite small, 10 to the -2. And if this hypothesis is correct, total number of this record should be equal to number of atoms, should be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? And there is another segment where with accelerations and forces, but it's not as important. So, in fact, if we would live not in the Stone Age, but say 25 years ago, when VASP code was already developed, but computers were somewhat slow. So I'm not telling something practical, but instead of running heating job, we can just create artificially this segment with velocities and put here some velocities with random numbers. which would correspond to assigning random velocities. It will be not most efficient, but it will save time on running job. Okay, so this cont originates from the word continue. And there was one question, like if queue time is limited on the cluster, how you do half of a job today and half of a job tomorrow? You do smaller number of steps, wait until cont car is formed, and then copy cont car into post car. So cont for continuing. And we are literally practicing this continuation. You are typing copy cont car of this job as a postcard to new job. Now I'm going to this new directory, which has postcard, podcar, key points. It does not have in-car. So I'm copying from the template bin in-car MD period here in car. So let me copy this command to the chat line as well. Copy. Paste. And now I may want to edit this file, the info. So this Iberian 0s-3, it's corresponds to molecular dynamics without heating. The keywords for the temperature are also here, but they, if you have too many information for today, you can just skip them. If you're curious, the temperature with these parameters means different thing. It is electronic temperature, if it makes sense to you. So ionic temperature corresponds to velocity of ions, and electronic temperature is temperature that defines Fermi-Dirac distribution, thermal smearing. And it's not part of our course, but one of the attendees of the class, and I think it is not a secret, I can reveal the name, Kea was asking why occupations of HOMO and LUMO sometimes differ from 2.00 and 0.00. You may, in your
I'm asking.
right?
Yeah.
In your homeworks, you may have observed such instances, right?
Yes.
So if the system is close to metallic, by good or wrong, right or wrong reason, if the energy gap between HOMO and LUMO is small, WASP is trying to be smarter than humans and automatically populate orbitals close to the gap according to Fermi-Dirac distribution to model thermal promotion of occupation from HOMO to LUMO. And this temperature is a parameter that defines this procedure during the molecular dynamics. If you're curious, if you don't care, it will not change much. Just keep this as is. Now,
that's comment on Postman, where we
this one, copy template MD to in-car. This one, okay.
have to use. You are done with
Yeah, so to avoid confusion. I apologize if we are going too quick. I'm just trying to save time and complete everything. So I am trying to work in parallel.
Professor,
So-
I have one question.
Just a second, I'll answer to Lina and then answer to your question here. So I'm trying to work in parallel. I have two windows open. In one window, I work on photon. In another, I work on NERSC. Since we try to finish the lab in 2 hours, right after I completed explanation how to run heating job on the NERSC, I immediately switched back to photon, and now I'm telling how to write molecular dynamics job on photon.
This
Okay.
is for both.
On
We can use it now because it's done.
Mhm.
We developed that.
Yes, yes. Okay, your question?
So why you need to change the value in there?
Can you please bring microphone closer?
So in car, why you need to
Huh?
change the value of the NSW always? We can use this.
Good question. Good question. I like it. So the answer to this question is a balance between precision and numerical efficiency and human assessment of a computer that you are using. So the larger NSW for heating, the better is representation of thermal equilibrium on one hand. But on another, we all are humans and we just sometimes are impatient. We cannot wait too long, right? So, if we need only qualitative level of results, you may give up precision and do things quicker. If you run job on a photon, this consideration is critical. We just do not have luxury to run long jobs. If we are running jobs on the NERSC, which flies like crazy, there is no problem to run this 300 steps or more. So therefore, we return this value of NSW back. Okay, did it answer your question?
Yes.
Okay, yeah, thank you. So I keep going forward through the template of the in-car form for molecular dynamics. So I scroll further, and here NSW is 1000. This, when I will be repeating the same job on the NERSC, I will keep it 1000 or maybe like 300 to speed up a little bit. For photon, I definitely do not want to get more than 30. So it will be not very informative scientifically, but it is the only thing I can do in the remaining time. So I change this NSW to 30, escape on WQ, and now PWD. I am in the directory which I intentionally created to run molecular dynamics job, and there I do submit the bus photon job. Just in case if someone will ask me to show previous commands so that I do not block the screen, I can forward the output into something like my output file and put ampersand so that it doesn't garbage screen. Then I can type more commands. So process number 65,000 something is last on the photon, and then this my output. No? Well, so the output files are getting generated. So I'm going to visit in-class attendees and then online attendees to make sure that you have submitted molecular dynamics jobs on the photon. And after this, I will do demonstration on submitting molecular dynamics job on NERSC, and right after that, I will do demonstration of BMD. So we have about 45 minutes for this program. you won't, but you, you became like a professional scientist in production, which look at you, you said it before. Well, maybe they are. This and anything that is bigger than roughly the same time as your question is this one. So, if you see the waiting capital potential, and I'd like to look at that in a second. I would like to so our sorry. My bad. So you can use maybe later on something that so it's pretty cool. Yeah,
So yeah, it was tough.
Where it's empty.
That'll do it. Okay. So,
We're serving two dots here. And here you have a couple of things for the different, but now we are in the cross. Positions. No, oh, we need to cross. Yes, but we also need potential. No, we need to cross the template.
I suppose with a lot of people, what they want stuff, it's needed. I have. I put the two servers.
Huh? Yeah. Yeah. and putting this smaller number to the number 14. And if you don't want to publish my screen, the rest of that. Okay. Put this side. It will still run, but if you have a more extra task, you need to
I turned over. Or down the tower.
it will be finished at the time when the job is done. Now it's empty. As you progress through, as the job is done, it will should notice it, yeah, I think it. So it goes well. With this skill, or you can do project that you will be limited by the performance of it. I'll show it soon.
So like,
Do the same thing.
obviously we all are signed.
Okay. Good. Now,
So like,
one.
what is that? Make it this right.
Okay. I want to cut or SP or C. Then I need to cut on the field. One, four, here. Into the right. So we are taking from bottom. One. And one tracing password for bottom. Now there is no option or it is not broken. Putting to run jobs. But if you huh? Just from here there another template. So I did copy the first the problem with So,
Yeah, I mean.
there is no everybody is not often. Or just fix it.
I got the first.
Much better. So it was two ambitions. No, and 64 courses. Quicker. Um, just trying to be less less resources. So it means 1,064 courses, but if you use this template, I'll fix it for everyone. When you use in the future, for example. No, what is available here. Like it's, run. So this job for
Oh,
now we set up a position.
Everything.
Here, here, goes.
say it like just the other day. I did the start right now.
I have a program game. I changed it. Yes. We should rerun this. That would have a bit of a progress. One better. The job is done, but you want to continue. Please card into postcode. People to run.
Well, I mean, that's good to know because I do sort of believe it's definitely sort of early conversations. And I have them good fun.
If you look through,
There's no meaning, so
go quicker and understand. But basically, you're already done with Sarah, would you like to share screen?
Yes. It seems
You will
that it finished.
Okay, excellent, excellent. We will be a little over the time, but not much. Okay, I think everything is good. You can stop
Okay.
sharing. Kay, would you like to share screen? What is going on? Can you do?
I don't know what happened.
Your in-car does not exist, right? Can you type more space in-car? More space in-car.
I changed in card.
Enter.
After that, it.
No. Okay.
What happened? I
Please do CP
don't-
CP space tilde slash
Just a minute. Yeah.
wavy line. No.
Hmm.
Wavy line tilde slash bin bin slash in-car slash in-car dash md minus md md space period. Enter.
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 Okay.
Arrow up.
Mm.
Divide or slash in-car enter. Now type vi in-car, vi space in-car.
Oh, connection to the remote PC lost.
It happens. Do not worry.
What should I do? Just I don't know. Internet connection. Oh, because of the internet connection. Just 1 minute, Professor.
Yeah, that's okay. That's okay. Okay, vi in-car. Enter.
Yeah, and then go down.
So go down to the second last line and change this NSW from 1000 to, let's say, 30. Otherwise, it will be too long.
But Professor, last time I did, and then it shows 0.
30, escape, escape, colon WQ. Enter. ls minus OT. Enter. So you have in-car, postcar, podcar. Do you have key points? You have key points. Okay. And now launch WASP. Tilde slash bin.
This
Yes. Yeah, this one. Enter.
one. Yes. But Professor, what happened? Last time I did the same things, and after that, this kind of things happened with me when I did the last homework. So what happened actually? I save. Change the number in SW, then I save that one. After that, it shows that there is no in-car file. Why this kind of things happen?
I don't know. It is something strange. Well, you see now it works.
Yeah, now it works. But before when I did it, but it shows that there is no in-car file. You saw that there is nothing. It's totally vanished from this section.
You should show it me. Send me an email when it stops working once again, and we'll work together.
Okay, I will.
It's a mystery. It shouldn't be this way.
No.
So now the job is working at your end.
Yeah, it will take time.
Yeah, you can stop sharing and I'll continue demonstrations. So, did I show molecular dynamics on NERSC to everyone? Yes or no?
No.
Okay. Yes, it was hitting. So now I am on the NERSC, not Foden, but NERSC, PWD. And I am creating new directory, make directory 2 dots MD. And right now I'm in the directory where I was doing heating, and I'm copying the cont car from heating to the directory of MD. And I may want to rename it into the POS car. Now I also want to share, to copy standard files, pod car, there, key points there, and then I'm going there myself. And oh, and I can also copy this SH files if I was doing it correctly there, so that I don't copy it from the template. Now I'm going to the MD subdirectory, ls-ot. So let's check if the postcar file looks reasonable. More postcar. Yes, it does have this segment with velocities. Now I need to, there is nothing smart here, but just in case, let me copy this commands so that only as an encouragement. You probably know what to do without it, but okay. And now I am missing the in-car file, the specific in-car file for the molecular dynamics. And it is also available in the same format as on the Photon. Copy bin in-car / in-car -md space here in-car. In-car. That's the same template. And 1,000 is a little too much for, since we are about to finish for today. Maybe 100 or 300 is reasonable. Escape WQ. And after this is done, oh, let me copy this command also, just in case. Copy. Check. Paste. And there was some vertical line which I didn't need. Okay. And now I am, just in case, let me check if the debug script is reasonable. Yes. So the make sure it was a question of Boston. So the shell script to submit job shouldn't be ambitious if you want to get into the queue quickly. So number of nodes 1, number of cores 64. It's maximum of the quick job. If you use less, it will be maybe quicker, but not as productive. And time limit is 30 for the debug queue. If by some reason you have different copy of this script, you may just check that those parameters are here. And then it loads WASP and request, so it runs WASP standard version on 64 cores. So I do s batch debug sh. After I submit, it gives me the job ID. Copy, and I can check how the job is doing. SQS grab this job ID. So it's already running on the node number 2793 out of 10,000 nodes. and it's running for 13 seconds. And more the car. So as we speak, it's already passed 2 ionic steps, but as we speak and as I will talk to you, it will continue more steps. Okay. So I am going to open another equipment and show things on the VMD. So what I am going to do, I'm going to log into either Photon and NERSC and pull the outcar file, outcar, from the molecular dynamics run into the local computer. You can do it by sidebar on the mobile extern. On the Mac, one needs to practice this SCP commands, and then I will open VMD software and try to open outcar file. That's it. And then you will see me clicking some buttons with mouse and atoms move. So it will be the last thing for today. So it may take me a couple of minutes before I open and log in, but it shouldn't take time, and we can spend maybe 10 minutes longer than our designated time, but we are doing reasonably well. There could be a feedback from microphone for a second, but I will disable it. And let's hope that so we got about 100 steps here. So while I was speaking on Earth, that job is done. Now, I want to make directory LD NERSC. NERSC PWD. Yes, I can copy only outcar which will be wiser, but I can do also rsync everything from NERSC in this directory into NT. And then I'll paste the path. And I type the password for the photo. So I did transfer all files. Now I go back to the window where I'm logged into Photon, and files from NERSC are transferred there. I will need only out card. So stop sharing, and I need to give okay, I already made myself a co-host. Now, on the local computer, I first quickly log into Photon because I do not remember this path. PWD or PWD. So I need only this little path. And then I can exit from Photon. And here I am on the local computer, and I want also to copy every. Well, I actually need only out card, but I can copy everything. So because files, when we will start actual calculations, it's smarter to copy only designated files. But for this little examples, they're so small that it's ridiculous. So open. Now I'm pasting the path. So everything from Photon this directory into here. Network looks safe. So files are here, just in case. Out car file is here. Now, here is the VMD, and I just looked on the charge density, and one can look also orbitals there. So I want to, I do not want to look on these things. And I want to open this out card. I click new molecule. Browse. And then I need to find the directory where I have copied the stuff. if we are describing. So, check it. Oh, I copied into the wrong class. Okay. So I need the outcar file, and it does ask what is the format of file. So I select VASP outcar, and after selecting this VASP outcar, I can click load. So after I click load, it goes for this 99 steps, and it brings here this molecule. It doesn't look very spectacular right now, and I do want it to look spectacular. So I go to graphics representations and select, for example, CPK. Now it looks a little bit better. And also there are ways to display orthographic. And one can also click show names as classmates. So the periodic images. And after that, I can click on this run button, and it will show how the molecule changes over time. So this is a little boring because this nanowire is not breaking bonds or not participating in the chemical reactions, but we did this little exploration just for the proof of concept. For the projects, we will select such examples where some chemical reactions of dissociation or association are going on, and it will be most important things. So if I can look from different angles. So please try to download files to your local computers and make this play of the movie. And I will do last circle over the seats, and then we will be done for today.
Oh, excuse me, Professor, should we download the outcard from Photon?
Whatever is comfortable for you. What I did. I did run molecular dynamics on NERSC. Then I downloaded or uploaded results of molecular dynamics from NERSC to Photon. And then on my local computer, I downloaded the data from Photon. So there is a little barrier between simple users like me and NERSC. So it's much easier to transfer from NERSC to Photon and then from Photon to local computer. If you download your molecular dynamics that you have generated on Photon, it's fine. It will be just shorter trajectory. Make sense?
Yes.
I'm going to stop it. Here, stop. And I can also extension visualization movie maker. So this movie maker is expected to fabricate the movie. Okay, I'm going to circle around seats and make sure that you can just make it to move on your screen, and it will be more than enough for today. And later on, maybe next time or on the recordings, I'll tell about making movies. But I worry that I take more time that you probably have already plans for the evening. So,
Yeah, very light on original.
Trying to or whoever will
I don't know what that's
Oh, not a problem. Not a problem. So it's you are bottom. You already wrote both. So you no. Given. Let's find it. This one. Does. Okay. Desktop role. Twice. just trying to. It doesn't show spectacular things, but one can include graphics. It will not work today. Close. Tries to make it, but then it doesn't show where this video. So this is the free software on the computer, and it will make videos. But basically, okay, so last step before we depart for today. So Sarah, would you like to share screen?
Yes. Oh. My model doesn't have font. No.
Oh, that's easier. That's easier. Thank you. Thank you. Can you make it a little smaller and so that we have a window for yes, this one. So let's go to graphics, representations. Okay. Now click on the button Create Rep. Slowly move mouse up. Yes, Create Rep. Now move mouse down, a little bit more down, more down, down. Yeah, more, stop, more here. And instead of CPK, select the dynamic bonds. Good. Now move down and right a little. Distance cut off. So now it is 1.6. Try to increase it. Just arrow, yeah, click. Okay. And now you can return back to this main menu and click triangle at the bottom right. Bottom right. Yes. Click. So it looks like due to, so we heated up the model to quite high temperature. So it is on the, it extends through thermal motion, it extends the bonds to the range where they could be considered as broken. And to do realistic modeling of material, one may need to have a little longer trajectory. And again, here it is only learning example. We do not expect much of dynamics, but if we can model adsorption, desorption, association, dissociation reactions, and it will be hopefully inspiring and cool. Can you stop this motion, and I'll show a little another trick. Let's go to graphics representations. Graphics representations. Bring it to the center so that they see it. Now you in the middle you periodic. Do you see it?
Yeah.
Click and check on -x and +x. Okay, let's go to draw. Oh, no, wait. Slowly move to this CPK, up, move your mouse up to the CPK. Click here, and now check this plus and minus once again. And now run this triangle, yeah, here. So you see that although we explicitly model only 12 atoms, it models the infinite strength of this nanowire, right?
Yeah.
Please stop it. Just click once again, and go in this window to extensions. Click, move down visualization, and click Movie Maker. Movie Maker. Yeah, click here. We do not have time right now, but explore this window because it will be practically important and helpful. So, and talk to others in the class. It's maybe a little homework to learn what is video map. Just we are limited in time. I want to finish, and I need. You are done. Thank you. You have completed, and let's quickly check with Kaya.
Thank you.
Yep. Kaya, would you like to share a screen?
Of course. And this one, totally, what should I do? It stopped working. Please load.
Closer microphone, and we will have, just a second, we will not have anything new. I apologize that we spent more time than planned. Yes, please depart and disconnect if needed.
Okay.
And I need just to quickly check with Kay, and then we are done for the day. And those whom I already visited are free to go. There will be no new information.
Remove the earphone. So professor, it started loading and I'm not able to open this one. See.
Do not worry.
Maybe should I open another VMD?
No. Return where you were. Did you download the out card to your local computer?
I downloaded.
Please show me where it is in the command line.
Let me show you. Okay, it's connected with my. Before it's disconnected and now it's connected. Let me show you where I download.
Thank you.
This one in download section.
Okay, now you need to open this file with your VMD. File open. File new mode. Browse and find this file.
Out card.
Open. Now determine file type. Click. Yes. Scroll down. Keep scrolling to the bottom. It's quite a long list. 30 steps more. Down. Alphabetically, it should be near the word WASP. WASP out, yes. Click WASP out card. Click. Load. Now click on the main menu. The main. No. Shift this to the side. Yes, this one.
Yes.
It looks like your out card doesn't have steps. Can you open out card in the command line or as with some editor? Just show me which. Yeah. Go to the command line and show me what you did download.
I download from this section. This one. Oh, let me.
Slowly. So is too small. In the command line.
Should I write
please type PWD.
PWD.
Enter.
Yes.
Okay. Now go to the left sidebar.
There?
Yes. And on the, go up and click this green circle to renew. No, up, more up.
Hmm.
No,
one.
next green circle. Next one line up.
This one?
Yes. Click,
Refresh.
refresh.
Yes.
Now, can you please make the sidebar bigger and main command line small? Yes, pull this one.
Okay.
Okay. So let's compare. I think it is slightly different things. Okay. Go back to the command line and type more outcar, more space outcar.
Outcar. Okay. Enter.
Enter, and keep hitting space. Okay, you can type letter Q to stop.
I think.
Type
Q?
letter Q. Otherwise, it's too long.
Okay.
Yeah. Now type more Aussie car, more space O uppercase O Z, not S, but yeah,
Z.
O S Z. O S. You were correct. O S Z, and now tab Aussie car. Enter. Very good. Very good. Yes. So the files are good. Type once again PWD.
PWD. Enter.
Enter.
Hmm.
And now make sure that you on the left sidebar we are speaking about the same. We are focusing on the same directory. Maybe
Yes.
click this arrow up, green folder.
This one. Yeah.
No.
This?
Lower. Yes. Double click. And now click back on this MD 1000.
Yeah.
So you see, by some reason here, it shows outcar very short file. It doesn't show the whole. Oh no, kilobytes.
658.
No, it's good. Now let's try download it once again.
Yeah.
Download it.
Before delete it. Oh, it's 64 KB. Why?
Okay, and now go and
Download.
download to desktop or downloads. Yes, and now open it with VMD once again.
Yes. Let's try. Oh no, download section.
Mhm.
Let me check the. Yes, now it's.
Okay.
Okay. Need to go wasp. Pass outcar, then load. What happened?
Now click on the main menu.
Yes.
Yeah, so you see 29 steps in the lower right. Now click on graphics. Representations.
Yes.
And you see lines. Lower, slowly move, slowly, lower.
This.
Click here, change to dynamic bonds.
Yep.
Now you see distance cut off, increase
Yes.
it. Increase it more. Okay, enough. Now move mouse up and click on create rep. Create rep, slowly, create rep. Now move mouse down. More. And where you see dynamic bonds,
Yes.
click on CPK.
CPK. This.
Oh,
yeah.
Now you see spheres. Now click on the main panel, main control panel.
This one? This one?
Yes, this one.
Yes.
And in the lower right edge, very lower, there is a triangle. Click. Do you see?
What happened with this?
You see that atoms are moving, right?
Yes.
So it is to get this movie was the main goal of today's meeting.
Okay, so it's correct or not? Means,
It is
my
correct.
question-
It is
okay,
correct.
mm,
Everything is great.
So how it's correct, it's good, but how could I understand when I will do this one, then this one is correct? I need to understand by myself. It's correct. You said it's okay, but I need to understand by myself. And so what's the way to understand that this one is correct?
Well, right now there is nothing spectacular. Just we need to admit the idea that at ambient temperatures, at realistic temperatures,
Mhm.
all ions are moving,
Okay,
right? And they're moving near their equilibrium positions.
okay.
If there are no chemical reaction, they just
Mhm.
oscillate. If we will do some more interesting, if there will be adsorption, desorption, or chemical reaction, some bonds will be broken. If you can look for explosion or like vitrimers, there will be something more advanced. But right now, what we see is correct. You see just little oscillations near equilibrium.
Okay, I have one question that when Sarah shows her model, why it's like a broken things, you know? So if similar thing can be happen with me, so how to fix that one?
Stop. Just please stop this movie.
Yes. Oh, why I stopped hearing? Oh God, where is it?
So
Oh, okay, I need to go back to my home. Yes, this one. Okay.
yeah, this one. So if go to this representations,
Graphics representation.
yes,
This one. Yes.
yes, and click on the dynamic bonds
Okay.
here. Yes, yes. Now go back to distance cutoff.
Distance cutoff. This one.
So this is not a scientific observable. It's only a way how the molecule is represented. So
Okay.
this 2.5, 2.4 means that if atoms are
Mhm.
closer to each other than 2.4 angstroms, the program is drawing a line.
Mhm.
If the atoms by thermal motion depart
Mhm.
away from each other by a distance bigger than 2.4, the line is not drawn.
Okay.
But as a scientist, you can modify this threshold and set it up to different value.
Yes.
Okay?
Okay.
So it is not that in for one class D there were bond breaking and for another there weren't. It's just slightly different distance cutoff.
Okay. Okay. So for Sarah's case, she need to be change the distance cutoff. Maybe increase the distance cutoff.
Yes, yes, exactly.
Okay. And you just show Sarah video
Video map. Okay, yeah, click extension,
extension,
click
then
visualization, lower,
view.
lower, lower,
Yes.
visualization.
Movie
Then
maker.
go to movie maker, yes.
And what is this?
So click on the set working directory. Set working directory.
Yeah. Should I
click
keep
here.
click?
Click.
Okay.
Select desktop or whatever you some place on your computer.
Mm,
Desktop
where?
would be fine, but select something.
Okay. This on my homework.
Yeah, yeah. Okay.
Should I?
Okay. Just click OK to get something.
No, don't need to. There maybe. Let me check. Yes. Yes. Chemistry homework. Then
Okay.
okay.
Click OK.
Hmm.
Now go to movie settings.
Movie setting.
Click. Move a little down to trajectory.
Yes.
Click.
I already click.
Then click on renderer. Renderer to the left. Renderer.
Where it is? Oh, this one. Yeah.
Yes. Snapshots are good. Yeah. Keep. Yeah. It's okay.
Hmm.
And once again, movie settings. movie
Movie
settings,
setting.
uncheck delete image files.
Okay.
Okay. Now you can also check the word untitled to some word like my movie. Call it like or titanium dioxide, whatever.
My movie.
Okay. And
Mhm.
then go to very bottom and click make movie.
Make movie.
And now you see it shows could not locate videomark.exe.
Oh.
So this is a free software, and it will be like a little addition to your homework.
Mhm.
Find online and install this VideoMax software, which will enable to create movies that one can upload to YouTube.
Okay. Okay, I can understand. Means what I'm doing here, it will be create a video, right?
Yes, right now you only visualize things on your screen.
Mm-hmm.
But if you add this little piece of software, which is free, videomark.exe, you will be able to generate movies that one can share, send to your collaborators, or submit to the journal, or upload to YouTube.
Okay. Okay, it's fine. Thank you, Professor. Oh, I have a question. Remember, I asked you a question when you explain something. You said you will explain me after in the end of the class. Question.
Do you remember what I was promising? Because I'm already empty-headed.
This one is like this. Um, the graph you showed. So I
Oh,
asked
the one on the
graph.
board.
Graph. Yes, board.
And what is not clear? Just
There, Professor, you just quick demonstration. The upper line. You showed that row knot. Yes, this. This one is row knot, right?
this is what?
You wrote something there, row knot. Just
Oh, P0.
oh, this one P
P.
pressure.
No. Momentum.
Momentum, okay. Momentum.
Momentum, same as velocity. So let me erase this thing.
Yes.
So if we set up momentum,
Mm-hmm.
then momentum squared, E squared over 2m,
Mm-hmm.
is kinetic energy.
Kinetic energy. Yeah, last class you
Yes,
showed.
and the distance minus equilibrium distance squared is potential energy.
Okay.
So this arrow. And kinetic plus potential is total energy, which is constant.
Okay.
So which is symbolized by particle moves on the equal energy line until turning point, and then it returns back.
Okay. And why you wrote that equations for momentum and this one, what is this?
Because I want everyone in class to understand what is heating and molecular dynamics.
Okay. Now it's makes sense. Yeah.
Okay.
And the for a NE is, oh my god, NESCR?
NSW?
No, not NSW. The another we are using in photon. You use another one.
Oh, NERSC.
NERSC. Okay. We need to do that one. Means the part 4 is related to the NERSC. Okay, I will do it, and this time I definitely send you email immediately. Oh my god.
Please. I will enjoy it.
Oh my god, last time how many time I spent on that. Okay, Professor, thank you so much. See you on Friday.
No, I
No?
would be happy. I would be happy to teach on Friday, but I think it's university is closed. It's like
Oh, I forgot.
celebration of Easter on like Western calendar.
Oh, I forgot. Actually, I forgot.
So if everyone votes, I can. It's not a problem for me to deliver. But by
No one will.
laws of
Maybe only me.
university assumed to be like a vacation on Friday and Monday.
Mhm. Okay. See you on next week. Okay. Bye.
Tuesday. Tuesday.
Yes, Tuesday.
Okay. Yeah.
Bye.
Thank you.
Have a nice weekend and holiday.
Thank you. You too.
Thank you.
Yes.